Okay, welcome to another Ginger Mathematician video here, and we're going to go through everything to do with similarity. I've had a couple of requests for this kind of video. So let's get started on this part D, and we're going to combine some other topics in here, things like circle theorems and mensuration as well. So GKM, lie on the circle, center O. FGH is a tangent to the circle at G. So notice this line that goes across just touches the circle and then goes off. And MG is parallel to OH. So that's why we've got these arrows here and here. And we need to show that triangle GKM, so it's worth identifying which triangle this is. So this one here. So GKM, so GKM, so those letters there, is mathematically similar to triangle OHG. So when you do a question like this, it's quite useful just to label the two triangles that we're focusing on. That makes it easier then to work out what is shared between the two triangles. Give a geometrical reason for each statement you make. So this is where this kind of question is a bit more like science, because you see there are 4 marks available for this. So we're going to need to put down 4 bits of information as we go along. So the first thing to notice here, and this is a circle theorem, again, if you're not sure about circle theorems here, then do check out the video above, is that if we take GOH, notice this angle here is a right angle. A tangent meets a radius of a circle at a right angle. And in a very similar way, if you take a diameter of the circle, then 2 lines that come out from the diameter also meet at a right angle as well. So notice they've integrated some circle theorems into this. What this means then is that angle GMK, now how do I know to use this notation? GMK, so M is where the angle is, and then G and K are the points surrounding it. Okay, and we're going to get lots of practice on this. And then we look at OGH. Notice G is where the angle is, O and H are surrounding. And if you're thinking, well, why not put down HGO? Well, that's also absolutely fine too. So these two angles are the same and both equal to 90 degrees. And we need to write some reasons. So tangent meets radius at 90 degrees, and then the other reason here, the diameter, so lines from diameter. Again, not much room to put all this in, but it's important. From diameter meet circumference at 90 degrees. I'll show you the mark scheme afterwards to see, you can make this a little bit shorter in terms of the information. So we have those 2 angles that are shared, which is very, very important. Now what we're going to do is show that 2 other angles are the same. And the angles I'm going to pick on here are this one here. So this angle here, so this is GOH. I'm going to show this is equal to this angle down here. So that's KGM. And the reason they're equal is another angle fact you need to know. Again, a very useful angle fact that comes up a lot. So if I do this now with my 2 triangles, notice there is what's called informally a Z angle. And so we need to give the proper reason for this. We need to use the right language here. And the reason is that alternate, so the Z angle is known as alternate angles are equal. So it's really important you put these very clear reasons down as you go. So if 2 angles are the same, then it stands to reason, if we look at the very last angle that we haven't considered here, these 2 must also be the same as well. So GKM is equal to OHG. Now, there's a couple of reasons you can put for this. You can say third angle in triangle. That is absolutely fine. But hopefully some of you have spotted out there, this is also the alternate segment theorem. So this angle here must be the same as this angle here for the alternate segment theorem. Again, I really encourage you to check out my circle theorem video if you're not sure about that particular idea. And because then the 3 angles are the same, so all 3 angles the same, you can write down AAA as well if you so wish, are the same, then they are similar triangles. So they are similar triangles. So we've got all the information there for the 4 marks. Let me break that down. So the first part is showing they're 90 due to those 2 circle theorems, 1 mark. Then alternate angles are equal, therefore that's 2nd mark. The third angle in the triangle, therefore they're equal, and therefore some context sentence at the end saying, because all 3 angles are the same, the 2 triangles must be similar. And you can read through the mark scheme very, very carefully. You can see where I've picked up all those 4 different marks. Again, we had some alternatives here about not using alternate sequence, just using the idea it's the 3rd angle in the triangle. That is also fine as well. Okay, and on to a more classical kind of question here, so question 11. Again, whenever it's a similarity kind of question here, they are going to write down that phrase. They're going to write down mathematically similar. So that's a great trigger word to use to go, I need to remember this video that you're currently watching on similarity. And what we need to do here is calculate the side QR. So again, it's always good to know exactly what side we're looking for. As soon as I see a similarity question like this, I'm thinking scale factor. Now, what do I mean by the scale factor? Well, the way that I would work this out is I take 2 corresponding sides of the shape. Now, what do I mean by corresponding sides? Well, the same side in both shapes. So AB here and PQ, like so. Again, they're both the bottom side of the shape, so they're corresponding to each other. And then I take one and divide it by the other. So 8 divided by 6. Now you could do it the other way round as well. I'm going to stick with big divided by small. Now if I do that, again, we're just going to divide both by 2 and we get 4/3. You don't need to rush to a calculator with this kind of question. Try and be happy to leave it as a fraction. Now what we need to do here is work out RQ, so QR, so that's what we're looking for. And notice we're going from big to small. So this is the big triangle, this is the small triangle. So if I'm going this direction, I want to be dividing by that scale factor because I want to go from big to small. If I was going the other way, it would be multiplying. So all we're going to do is take the corresponding side to RQ in this shape, which is BC here, so therefore 6. And all we're going to do is we're just going to do 6 divided by 4/3. Now, of course, you can use your calculator for this. That is not a problem at all. I'm going to do some keep it, switch it, flip it, because that's good fun. So keep this, switch this to a times, and then flip the fraction. Again, that is also absolutely fine too. And if I work this out, this is 18/4. Again, use your calculator. It's a calculator question, and that's going to lead to my final answer here of 4.5. If you're wondering where that comes from, well, 18 divided by 4. You can always use the bus stop method. That's always good fun. And we get 4 there, carry the 2, 4's into 20, go 5. Again, like using non-calculator methods, but of course you can just use a calculator at that point. And a very normal follow-up question to this is they'll do something to do with prisms here, so mathematically similar prisms. And the way I read this question is the volume, so that's really important here, of the larger prism is 320. We want the volume of the smaller prism. So as soon as I think of volume, I'm going to be thinking of volume scale factor. Now you're probably thinking, well, how do I work out volume scale factor? I just have the scale factor, 4/3, from the previous question. Well, all we do is we take that 4/3 and we're going to cube that number. Okay, because notice we've got centimeters cubed or cubic centimeters. So we want to take that and then cube it. Now again, we can use a calculator here, but if I cube this, we're going to get the same as 64/27. 4 cubed, 64, 3 cubed is 27. Now we're going to do the same logic here. We are looking for the smaller prism, so we're going from big to small. So we're going to divide by this new scale factor. So to work out the new volume of small, just to remind me what I'm doing here, I'm going to do 320 divided by 64/27. And definitely in this case, I'm going to be using my calculator. Okay, so we're going to type in 320 divided by, let's get the old brackets working and fractions working, 64 divided by 27. Again, know your calculator, and we get the precise answer, which is a good sign, because usually in these questions you get a precise answer here of 135 cubic centimeters for the 2 marks. Again, you can check the mark scheme here. Again, you get a method mark for cubing that scale factor. Again, either way round. Notice I used 8/6, but you could also do the same process with 6/8, as long as your times you're multiplying correctly too. And on to another kind of language structure question here. So again, we want to be reading the information carefully. So in the diagram, AB is parallel to PQ. So notice we've got these 2 arrows here to represent that in the same direction. AQ and PB intersect at X in the middle, and AX is equal to XQ. Also given by these 2 lines here. So we're showing that that length is the same as that length. Complete the following statements in triangles ABX and QPX. So the 2 triangles we're considering here, which I think is fairly straightforward to see, is this red one at the top here. So we're thinking about this one, and then also the blue one here. You just be a little bit careful, because we need to be thinking how they compare. So it's good to identify what triangles we're using. So angle BAX. Now, which is BAX here? It's this one over here. BAX. A is where the angle is. B and X surround it. Now that's equal to, and now we need to put down the angle. Well, we're going to use a similar process to what we saw before. Notice we've actually got another Z. Always watch out for those Z angles. So notice that these 2 angles are the same, and we want to identify this correctly. So PQX, because alternate angles, remember that word from before, are equal. It's important to put down are equal, because some of these rules, that's not always the case. And now angle AXB, so we need to identify that. Let's use a different color. So AXB, X is where the angle is, AB surround it. And that's equal to, well, it's equal to the angle here. So look at this angle here, so that's PXQ. And it's a fact we haven't talked about. So when you have angles that are next to each other in this direction, there is a special phrase we use, and that is vertically opposite. Vertically opposite angles. Key language you have to know for your IGCSE exams. And vertically opposite angles, as you probably can see here from the diagram, even though it's not to scale, vertically opposite angles are equal. Again, I think it's important to write are equal. Again, the mark scheme may differ. And then triangle ABX is congruent to triangle QPX, i.e. the same. That's what congruent means here, just the same, because of the congruency criterion. Well, you should be familiar with these criterion here of SAS, ASA, RHS. Again, I'll explain most of these through this particular video. The congruency criterion we have here, well, we have 2 angles the same, so angle, and notice we're given at the start that AX was equal to XQ, so those 2 sides were also the same. So the congruency criterion is equal to ASA, so make sure we write that carefully. And therefore, the side PX, so this side here, must be equal to the side XB. So these 2 sides must be the same. If these 2 sides are the same, then these 2 sides must be the same. So I'll put 2 lines there to show that. And that's because the triangles are congruent, i.e. in normal words, they are the same triangle. But we use this word congruency. Again, a very different video to some of the videos I've done before, where it's all about focusing on that language and making sure we write it correctly for those 4 marks. So you can check your answers there. Again, they're quite loose here. They're just, if you put alternate or vertically opposite, they'll give you the mark even if you don't put are equal, but I think that's important too. Okay, on to our next question. Again, similar structured question. You can see these come up fairly often. So in triangle ABC, AC is equal to AB. Yep, they've been given these lines here to indicate they're the same. D is the point on BC such that AD is perpendicular. That's the important words. That means meet at 90 degrees. And lots of good language in this video today. And notice they give us a right angle here too. Complete the following statements to show that triangle ACD and triangle ABD are congruent, i.e. the same triangle. Okay, so which triangles are we looking at? ACD and ABD. Okay, so both sides, yep. So we're looking at this triangle. So ACD. And this one here. Again, they structure it for us as we go through. So AD is perpendicular to BC. So AD and BC. Therefore, angle, well, I think it must be meaning ADC, which is the angle we're given, is equal to, well, this angle over here. So ADB. And they're both equal to 90 degrees. So I think that's fairly straightforward. AC is equal to AB given information. Okay, that's nice. Which side is common to both triangles? Well, they both share this side down the middle. So they both share this one here. So that's called AD. So let's write that in. And then triangle ACD is congruent to ABD because of congruency criterion. So we had this list before. So one of these. And notice they have two sides at the same. So this one is shared and this one is shared, and they share the angle in between. So I would be happy putting down SAS here. However, this is quite a special one here where we have a right angle, the hypotenuse of the triangle, and another side. So they call this RHS, right angle hypotenuse side, but essentially that's a sub-variation of SAS. Notice right angle is this one, hypotenuse is this side, and then this side here as well. So I think the mark scheme will want RHS here, but notice that SAS is basically the same thing. And interestingly, they do actually just accept RHS rather than SAS. I would certainly dispute that. I think you should be able to accept both personally. Okay, and on to the next question here. Again, very similar kind of questions. This is why you watch these videos, to really see the patterns between the questions that come up. And in triangle PQR, so that's the whole triangle, so that's the whole triangle that goes around the outside. Again, M lies on QR and S lies on PR. Okay, probably don't need to put the ink there. Explain giving reasons why triangle PMR, so let's identify that. Okay, well, we've got this. This is our PMR. Oh, a little bit on the wobbly side. It's fine. Saved it. There we are. Is similar to triangle MSR. Okay, so that's the smaller triangle inside. And we need to find out why they are similar. Okay. You can't just put they're contained within each other. That doesn't work. Right, so PMR is equal to MSR. Right, so notice that this is a right angle here. It's on the same straight line. And we've got a right angle here as well. So they share this right angle. So we need to write this in nice and carefully. So PMR is equal to MSR. And they're both equal to 90 degrees. Again, I think that's quite clear why that's the case. I don't think we need to write any more reasons on that. The next thing to realize is they share an angle. So notice that this angle is the same in both triangles. So again, we need to identify this carefully. So angle PRM is equal to SRM. So shared angle. So that's my second piece of information. Okay, so we've got two angles. Now, I think that makes it actually quite easy now, because the last angle that we haven't mentioned yet, where did my pen go? My pen decided to disappear. There we are. So, if this angle is the same in both, we've got a right angle that's shared. That must mean the last angle we haven't talked about, so this one and this one. So, MPS must be equal to SMR. Don't worry, won't do any SMR videos here. And that's because it's the third angle in the triangle. You know, 2 are the same, and the other one must be the same as well, because they add up to 180. So therefore, and we can write down AAA, or all 3 angles. So that means the triangles are similar. You don't need to overcomplicate these questions. As long as you find 2 angles, then you can find the third angle is going to be the same, and therefore the 2 triangles here will be similar. So we'll go through part B, and then we'll come up. You can just see the answers quickly here. So you can see putting AAA gives you that third mark, which is important. On to question B here. So again, this very classical kind of similarity question here. And as soon as I see similar in the triangle, I'm thinking scale factor. It's the first thing that comes to mind. So the way that we find the scale factor is we look at corresponding sides. Notice we've got the long side here, BC, and QR, which is the same side in both triangles. And I will work out the scale factor by doing big divided by small. You can obviously do it the other way round. So we do 9.9 divided by 8.1. Again, let's use a calculator for it this time. So all we're going to do is just going to do 9.9 divided by 8.1. I'm sure some of you already know the answer here. So 1.222 recurring. So I'm just going to leave that as 1.22 recurring. I do want to show you how you actually use it when you do get something recurring and you don't get any rounding errors. I'll talk about that in a subsequent video. And we want to find the value of x. Okay, so to work out x here, we take the 4.5. Notice the 4.5 is the same on both shapes here. And because we're going from small to big here, so going from 8.1 to 9.9, then we want to multiply by the scale factor. So we're going to multiply by the 1.22222. So let's go back to the calculator, use what we have. Okay, so we take our answer and then we just multiply it by 4.5. Just being careful, pressing the right buttons. And then we get the final answer, precise answer again, of 5.5, which is always a good sign. So we pop in 5.5. And now we're doing an area question. So the first thing that comes to mind, area of triangle is 25 square centimeters. Calculate the area of triangle ABC. Okay, so we know the scale factor, but I see area in the question, so I want the area scale factor. So we take that fraction, 9.9 over 8.1, and we're going to square that. Now I'm not going to rush to my calculator straight away because we need that in another part of the question. We want to work out the area of triangle ABC. Okay, now we know the area of the bigger triangle, so we're going from big to small, so we're going to divide. So we take our answer of 25, and we're going to divide, because we're going from big to small, of this new squared scale factor. So once I've got that exact calculation down, now I'm going to go to my calculator. Okay, so it was all about being careful in the calculator here. So 25 divided by, get the old fraction out here. I'll put this in brackets. So 9.9 divided by 8.1 all squared. Press the enter. And this time we don't get a precise answer, but with area and volume that can happen. So we get 16.73. 16.73 ... And we're rounding here to 3 significant figures or 1 decimal place. So we're going to get 16.7 for our precise answer for the 2 marks. Okay, so you can check through now part B to that question as well. So this came from a paper 4. Notice these kind of questions can appear in papers 2 and 4. So you just need to be aware where it can be on both papers. Okay, on to question 12. Again, another sort of classic similarity question. Hopefully you're building up your expertise as you're going through this video. Now, triangle PQR is similar to triangle ABC with PR divided by AC. So this here divided by this to be equal to 2 over 3. Now, so they've written this scale factor slightly differently, and we're given some extra information. So AB is 9, and we're going to area of triangle is 18 square centimeters. And we want to work out this one here. Okay, now generally when I do a scale factor, I go from big to small. Notice I've gone from small to big. So if I did AC divided by PR, notice that would be the fraction flipped. So that would be 3 over 2. I try and keep consistent with my methods here. It makes the next part a bit easier. So we want to find the length of PQ. So we're going from big to small, just looking at our diagram here. And if this is 9 and we want to find out this, then PQ will be equal to 9. Because we're going from big to small, we're going to be dividing. So we divide by 3 over 2. Now if we do that on our calculator, which I've got ready over here, so we do 9 divided by 3 over 2, giving us the answer of 6. Again, you can do that on your own calculators as well. And now to find the area of the triangle, well, I'm going to take my normal scale factor, which was this over here, and we're going to find the area scale factor. So we're going to do 3 over 2 squared. Again, I could work this out. I can also leave it as it is. And because we're going to, again, big to small, we work out the area of PQR is equal to 18, so the smaller one, sorry, the bigger one, sorry, divided by 3 over 2 all squared. Again, you can pop that into your calculator. So I'm going to quickly do that now for you. If you pop that in, you'll get the answer of 8. So we pop in 8 there. Key thing to watch out in this question, notice when they're working out the PR divided by AC, notice they were doing small to big, but I want big to small. It makes it easier to work with and more consistent as I go through the question. So you can see the 2 answers there, and you can see for what you need to get for the method mark. Okay, on to another similarity question. So we have 3 triangles ABC, and we need to find which 2 of the triangles are congruent, i.e. the same triangle. Now the easy trick to do here with this, notice if I look at A, I've got this 6 centimeters and I've got the 2 angles next to it. Notice in this one here, I've only got 1 angle next to it. I don't have this angle here. So A and B can't be the same. And if I look at this one, even though it's been flipped, this angle and this angle are next to the 6. So it must be A and C that are the same. And now I need to draw a ring around the congruency criterion that can be used to support the answer. Well, I have a side and 2 angles, so it must be ASA. 2 angles and the side. Cool, so easy 2 marks there, so you can just check that very quickly. Not much to check there really. And on to this question here. So 2 bottles are mathematically similar. That magic phrase is coming up, so scale factors are going through my mind at this point. And the small bottle has a capacity of 324 milliliters and a height of 12 centimeters. That's important. The large bottle has a capacity of 768 milliliters. Okay, this is a little bit different to questions that we've seen before. If you see the word capacity, and hopefully you know this from your science courses as well, then we're talking about volume. So when I take big divided by small, which I've done in a lot of these questions already, so I do 768 divided by 324. And I pop that into my calculator. So I go 768 divided by 324. Notice we get the fraction here of 64 over 27. This is not our normal scale factor because we're dealing with volumes. In fact, this is the volume scale factor that we have found. However, in the question, we're looking to work out the height. So we want the normal scale factor. And so if we take our 64 over 27, remember when we went from normal scale factor to volume scale factor, we cubed it. So going from volume scale factor to normal scale factor, we need to find the cube root of this, which is then slightly different to what we looked at before. So in the calculator, we need to work out the cube root of that 64/27. Let's go to my calculator and you see how I type it in. Okay, so this is where we have to be very, very careful where the cube root button is. And a lot of people just put a 3 in front, which is the incorrect thing to do. If I go to my calculator, I go control and this function. Notice I can choose which kind of root I want to put in the calculator. Because I want a cube root, I put a little 3 here. And now I'm just going to type in the fraction that we've seen before. So 64 divided by 27. Now you could do this without a calculator, of course, but notice you get your answer of 4/3. So really make sure and check on your calculator you are getting 4/3 when you work out the cube root. Now we want the height of the large bottle and we have the height of the smaller. So to work out the height of large, I tend to write that to remind me to times or divide. We're going to take the 12, and because I'm going from small to large, I want to multiply by 4/3. And again, this can be done without a calculator here, but this will give you the answer of 16, so which you can pop in for all those 3 marks. So you can check the mark scheme here. You can see you pick up 2 marks for doing this calculation correctly. I simplified this down to make it a little easier to find the cube root of. And if you've liked this video and it's been useful to you, then please do like it first of all so it can spread to as many people out there as possible. And if you just want to really get up to speed on all things mensuration, where similarity often comes in as well, then check out the video in front of you, because it'll take 1 hour to go through the real mensuration questions you need to know to do really well on those IGCSE exams.